The Convair F-102 Delta Dagger, often remembered as America's first operational supersonic all-weather interceptor and the first Delta wing fighter to serve in large numbers with the United States Air Force, represented a crucial evolutionary step in Cold War aviation history, embodying both the technological struggles and breakthroughs of the 1950s when the urgency to counter the threat of Soviet long-range bombers demanded rapid advances in jet design, missile systems, and radar integration, and though its eventual reputation was mixed compared to later fighters like the F-106 Delta Dagger, the more versatile multi-role aircraft that followed, the F-102 nevertheless marked a defining moment in U.S. air defense strategy and aerospace engineering. The project began in the late 1940s when the U.S. Air Force, concerned about the nuclear-capable bombers emerging from the Soviet Union, issued requirements for a high-performance interceptor capable of climbing rapidly, flying at supersonic speeds, and intercepting enemy aircraft under all weather conditions, with Convair eventually winning the contract, leveraging its earlier experimental work with Delta wings as seen in the XF-92A research aircraft designed by the visionary German engineer Drive. Alexander Lippisch, whose work on Delta configurations during World War II had inspired American designers. The XF-92A provided valuable aerodynamic data, demonstrating both the potential and the challenges of Delta wings, which offered low drag at high speeds and structural simplicity but created issues in stability, handling, and transonic drag rise. And when Convair translated these lessons into the prototype YF-102, the company initially faced a near-disastrous problem, as the aircraft's first flights revealed that its straight, thick fuselage design prevented it from reaching supersonic speeds due to excessive drag in the transonic region, leading to poor performance that threatened the entire program. The solution came with the application of Dr. Richard Whitcomb's revolutionary area rule principle, discovered at NACA, precursor to NASA, which explained that aircraft needed a Coke bottle fuselage shaping to smooth out airflow transitions around the wings and fuselage junction, thereby reducing wave drag at transonic and supersonic speeds. And after redesigning the fuselage with a wasp-waisted midsection to comply with this aerodynamic law, Convair produced the YF-102A, which achieved true supersonic performance and thus salvaged the program, entering service with the Air Defense Command in 1956. Operationally, the F-102 was powered by the Pratt Whitney J57 turbojet engine, delivering around 11,700 pounds of thrust dry and over 17,000 pounds with afterburner, enabling speeds of approximately Mach 1.25 at altitude, with a service ceiling of about 53,000 feet and a range of around 1,450 miles with drop tanks. And though not the fastest aircraft of its era, its climb rate and intercept profile matched the needs of Cold War air defense, where the primary mission was to rapidly ascend, engage high-flying bombers, and return to base, all coordinated through the semi-automatic ground environment SAGE system, which networked radar installations, command centers, and interceptors into a centralized defense grid. The aircraft's armament reflected its specialized role as a bomber-destroyer rather than a dogfighter, as it was equipped with internal weapons bays housing 6 AIM-4 Falcon air-to-air missiles, both infrared and radar-guided variants, and in some configurations a complement of 2.75-inch unguided, Mighty Mouse, rockets, but notably no guns, which became a controversial decision when later conflicts highlighted the enduring value of cannon armament, and the emphasis on guided missiles. And radar control positioned the F-102 as a transitional aircraft bridging the gap between early gun-armed jets and the missile-focused interceptors and fighters of the 1960s. The aircraft's radar, the Hughes MG-10 fire control system, allowed target tracking and missile guidance in coordination with ground controllers, though in practice its reliability and effectiveness were sometimes questioned, especially when compared to the improved systems on the F-106. In terms of design, the F-102's Delta wing offered excellent high-speed stability and internal fuel capacity but limited maneuverability and high landing speeds, making the aircraft less agile in dogfights, though this was not its intended mission profile, and pilots often described it as stable but unforgiving at low speeds. Production variants included the single-seat F-102A and the TF-102A two-seat trainer, which featured side-by-side seating and a redesigned canopy, and over 1,000 units were built in total, serving with the U.S. Air Force and Air National Guard units throughout the late 1950s and 1960s, with deployments in both continental U.S. air defense and overseas bases including Europe, Alaska, and Asia. Though designed primarily for nuclear-armed Soviet bomber interception, the F-102 did see limited combat use during the Vietnam War, where it flew air patrols and escort missions, and although it scored no confirmed aerial victories, it did engage in combat air patrols to deter North Vietnamese aircraft and occasionally performed ground attack missions using unguided rockets, a role far outside its original design. Attrition from accidents and combat gradually reduced its numbers, and by the late 1960s and early 1970s, it was phased out in favor of the superior Convair F-106 Delta Dart and multirole fighters like the F-4 Phantom II, though many Delta Daggers continued to serve in the Air National Guard until the mid-1970s, providing a crucial second line of defense during the height of Cold War tensions. Interestingly, several F-102s were later transferred to Allied air forces under programs like military assistance, serving with Greece and Turkey well into the 1980s, thereby extending the aircraft's operational legacy beyond U.S. service. Technically, the F-102 was a milestone as the first operational implementation of the area rule in a production fighter, directly influencing subsequent supersonic aircraft design worldwide, and though criticized for its limitations in agility, radar, and missile effectiveness, it was an indispensable stepping stone that taught engineers and pilots valuable lessons that fed into the design of more advanced interceptors. The aircraft's sleek delta wing silhouette, distinctive intake ducts, and weapons bay doors became iconic imagery of 1950s aerospace aesthetics, symbolizing both the optimism and the learning curve of missile-age air combat. In retrospect, while overshadowed by the higher-performing F-106 and the versatile F-4, the F-102 occupies an important historical niche as the aircraft that proved delta wings and area rule aerodynamics could work in operational service, and its widespread deployment ensured that the U.S. had a credible supersonic defense capability during a critical phase of the nuclear standoff. Moreover, the F-102's development illustrated the interplay between research institutions like NACA, industry innovators like Convair, and the urgent demands of military strategy, showing how aerodynamic theory could directly influence global security by turning a near-failure prototype into a frontline interceptor. In training, the F-102 was also valuable, as thousands of pilots gained their first supersonic delta wing experience in its cockpit, building the cadre of experienced aviators who would later transition to more advanced interceptors and multirole fighters, thus seeding the human capital necessary for sustained aerospace supremacy. From a broader perspective, the Delta Dagger exemplified how Cold War anxieties fueled rapid technological leaps, compressing decades of innovation into a few short years, and though it never fired its missiles in anger against Soviet bombers, the mission for which it had been created, its very presence in numbers contributed to deterrence, forming part of the strategic balance that defined its era. Ultimately, the Convair F-102 Delta Dagger must be seen not as a flawed machine but as a vital stepping stone, an aircraft that bridged the gap between early jet interceptors and the highly sophisticated supersonic fighters that followed, embodying the ambitions, challenges, and achievements of mid-20th century aerospace engineering.